Welcome to my YouTube channel Harible Coder, and in this video we are going to see the benefits of parallel execution via Java threads. Okay, so I think most of you who are hearing this video, who are seeing this video, definitely have heard about Java threads, but in this video I'm going to show you some interesting thing which I actually understood at a much later point about Java threads, and I want to show it to you. I want to explain that concept to you so that you can actually understand the core of Java threads pretty early. Now before we go there, Java threads can execute tasks in parallel. What it means is, say for example, I need to process some 20 files or maybe some 100 files, and they do not have any bearing on each other, they do not have any dependency on each other. So that's the perfect scenario where I can actually have multiple threads processing the files in parallel, and that's the power of a multi-threading programming language like Java. Now these tasks which actually run in multiple threads, this task can be of two types in the Java world. One is a runnable task and the other is a callable task. Runnable task is something where the processing is done but finally no value is returned, and the callable task is something where the processing is done and some value is returned to the caller. Now it is very important to understand the difference between the execution engine, and execution engine is the thread and the task. So the execution engine or the thread are the multiple engines or multiple lines of execution, you can say. So normally, if you do not have a multi-threaded environment, there is only one execution engine, which is the main execution engine. But in a multi-threaded program, there can be actually multiple lines of execution, multiple parallel lines of execution, depending on what you want to do. But what you actually want to achieve in parallel execution is your task, which you actually encapsulate or which you actually describe in your runnable or callable implementation. There is another interesting concept, which is the executor service, which actually helps in thread management, and that is an understanding that will actually help us further understand what is the difference between the thread execution engine and the task. But more about it in the subsequent section. But before I go into the subsequent part of the video, let me make a quick humble request to you. If you like my explanation, if you like this video, then please go ahead and subscribe to my channel and take a moment to watch my other videos and let me know your feedback. And if you like it, then please also share it with your friends who need that, who will be benefited from that, because that's something which is going to definitely help me, motivate me further. So with that said, let's proceed. So this is an example of a very simple Java program which spawns two threads, two runnable tasks, and then also another example where there is another Java thread 3, which spawns a callable task and then retrieves a response from the callable task. Don't worry about it, I will show a demo of this and then you will understand that in more detail. And now comes executor service. Now this is very interesting, and this is where we will understand what is the difference between the thread and the task. So thread is basically the execution engine. So nowadays what we always recommend to do is, instead of manually starting the thread yourself using thread.start, always use the executor service, which is a thread pool. So I can actually instantiate an executor service with a definite number of threads, maybe 2 or 4 or whatever. And then I can actually queue a lot of tasks. The tasks are nothing but my runnable or my callable tasks. Then I can queue a lot of tasks and I can actually send the queue to the pool, but the pool will only execute 2 tasks at a time. So if I queue some 100 tasks, then 2 will be executed and then it will give place for the next 2, like that. So it is very important to understand the benefit of this executor service. The benefit of executor service is that we do not need to spawn thread. The executor service is spawning the thread, so it has already spawned those number of threads, like thread 1 and thread 2 threads, and then it actually uses those 2 threads to run many tasks. Because since spawning thread itself is a very costly thing, it's a memory hungry thing, it takes a lot of memory, so that is why executor service is definitely a way in which we can reduce that overhead, that there are already threads which are available in the pool, and then whatever number of tasks which we want to execute, we can actually send to the pool and the task will be executed one by one. We will show a demo, we will see a demo of this, so please do not worry once again on this. But before I go to the demo, let me tell you one thing, that like all the frameworks, all the web application frameworks like Spring Boot and others, which are based on the thread concept, which are based on the multi-threaded concept, they all of them internally implement a thread pool. So whenever a request comes, they actually have a thread pool and they dedicate a thread to that request, to that specific task. Once that task is completed, then that thread gets freed and that thread can take up another task, which is another request. So this concept of thread pool is very important, and the segregation between the thread and the task is very important for us to understand how basically multi-threading works. See the demo? Please go to my GitHub channel, my GitHub repo once again, mshomik78, github.com/mshomik78, then high-level coder Java, and from there go to the branch thread demo, and everything is written here. Clone the branch, get it locally, and let me now show the demo. Like, this is a runnable task which implements runnable, and it has a task ID. It can have many other things actually. And then in the run statement, as you can see, that I have printed the task ID and I have printed the thread ID executing the task. So if I go back to the demo application, here I have created 10 instances of runnable task with 10 different tasks, 6 instances with 6 different task IDs, and then created 6 threads corresponding to each of the tasks, and then started the threads. If we run this, we will see that each of the tasks is run in its own thread. So you can see that task 2 is being run in its corresponding thread, task 3 in its thread, task 4 in its thread, task 5 in its thread, and so on and so forth. So that is where, so basically this has spawned 6 threads, and each of the 6 threads handles its own task. Now let us go and see the demo of the executor service. So here I am spawning an executor service with a fixed thread pool of size 2, but I am submitting 6 tasks to it. So the thread pool has got only 2 threads in it, but there are 6 tasks which are there in the queue. So it will execute 2 tasks only at a time. So let us go ahead and run this, and from the output it will be clear to you that it is running only 2 tasks at a time. See, it is first running task 1 and task 2 in thread 1 and thread 2, then running task 4 in thread 2 and task 3 in thread 1, and then running again task 5 again in thread 2 and task 6 in thread 1, because there are only 2 threads which I have created, which is thread 1 and thread 2, and those 2 threads are handling 6 tasks. So the tasks are queued and they are sent to the thread pool one by one. Once the previous tasks are completed, then the next ones which are in the queue are sent to the pool. So that is how the executor service works, and that is why I always say that it is much better, and it is always recommended to use executor service to run threads, and do not run the threads just by starting the threads, because number one advantage is executor service does not spawn a thread for every single task. So we need to decouple the threads from the tasks that they manage. So executor service is a very easy and a nice way for us to decouple the thread from the tasks which are managed, which are run by the threads. We can also run a callable task. So callable task, as I mentioned, is something which returns a value. So here the callable task returns a string. So ideally the callable task can actually do some processing. Maybe it can actually read certain lines of a file and then summarize the line using some NLP, and then can return the summary actually. So here is an example of a callable task, and I can also execute the callable task. And so this will run the callable part, the callable task using a future task, and then it will get the response back. Now the callable task will be run in thread 7, and it has returned hello world. So I did not give any print statement within the callable task, so that's why you did not see the thread number there, but that is fine. It has returned the task and I need to obtain it using future.get. I hope you enjoyed the video and I hope you had some takeaway from this video. Especially I would suggest the thing that you need to understand between the thread, the difference between the thread and the task. An executor service is a perfect example to understand the difference, and you should always use executor service. And I would like to end this video by again making that humble request that if you like my explanation and video, please go ahead and subscribe to my channel, and also view my other videos and share it with your friends and whoever you think would benefit from it, because that's going to motivate me further to produce quality videos. And please also try out the example yourself, because that would give you much more confidence. Thank you.